Welcome to part 3 of triple integrals and volume. I thought we should take a look at one more example. Here we want to determine the volume of the solid bounded by x squared plus y squared equals 9, above z equals 0, and below x plus z equals 4. So by now we should know that the volume can be determined by this triple integral, where v is the bounded three-dimensional region, and we integrate with respect to v, replacing dv with or any other order of those differentials. So let's start by taking a look at the xy, xz, and yz traces. So to determine the xy trace, we'll set z equal to 0. So here we'll have the circle centered at the origin with radius 3. And the region in this plane is inside the circle. For the xz trace, we'll set y equal to 0. Well, if y is 0, we'll have x squared equals 9. So x equals plus or minus 3. So if this is the x-axis, this is the z-axis. So we'd have a vertical line here and a vertical line here. And then we have this line x plus z equals 4, where we have both an x and a y-intercept equal to 4. So this trace would be the trapezoidal region as we see here, because we also know z is equal to 0, which would be here. And then lastly, for the yz trace, we'll set x equal to 0. So if x is 0, we'll have y equals plus or minus 3. We'll let this equal the y-axis and this be the z-axis. So we'll have two vertical lines here and here. And then if x is 0 here, we have z equals 4, a horizontal line through here. So the region in the yz plane would be this rectangle here. So let's see if we can determine the best order of integration as well as the limits of integration. The limits of integration for x and y will be affected by the graph of the circle, and the limits of integration for z will be affected by this line here. We don't want to use this trace here to determine the limits of integration for x, because moving from left to right, here it's bounded by this vertical line and this slanted line, and here it's bounded by this vertical line and another vertical line. So that would make things a lot more complicated. Let's go and integrate with respect to y first, which means the limits of integration for y must be expressed as a function of x and z. Since the equation of the circle was x squared plus y squared equals 9, if we solve this equation for y, we'll have y equals plus or minus the square root of 9 minus x squared. So the lower limit of integration will be negative square root 9 minus x squared, and the upper limit will be positive square root 9 minus x squared. And then to avoid having to integrate this result with respect to x because of the square roots, let's go to integrate with respect to z second and then x last. So the limits of integration for z, looking at this trace here, would be from 0 to this line. So we'll start at 0, and the equation of this line here was the equation x plus z equals 4. Solving this for z would give us 4 minus x. And then for x, the interval will be from negative 3 to positive 3 as we see here, as well as we see here. Before we start, let's go ahead and take a look at this three-dimensional region in space. The region we're looking for is underneath this slanted yellow plane, inside this blue cylinder, above the xy plane. So we're looking for the volume in this region here. Let's go ahead and start this on the next slide where we have more room. When we integrate with respect to y, we'll just get y. So when we sub the upper limit in, we'll have the square root of 9 minus x squared, and then minus a negative square root of 9 minus x squared. That'll give us 2 square roots of 9 minus x squared. Now when we integrate with respect to z, we're treating x as a constant, so we're just going to have 2z times the square root of 9 minus x squared So now we're going to replace z with 4 minus x and then with 0. Again, let's go ahead and do that on the next slide. So we'll have 2 times the quantity 4 minus x times the square root of 9 minus x squared. And then when z is 0, this will be 0. Now this is going to be 8 minus 2x. Let's break this up into two different integrals. So we'd have negative 2x times the square root of 9 minus x squared plus, and we'd have 8 times the square root of 9 minus x squared. Now the reason I wanted to do that is this is going to require u substitution, and this is going to require trig substitution. So here we'll let u equal 9 minus x squared. So differential u is going to be negative 2x dx. That's a perfect match here. The integral of the square root of u, or u to the 1/2 du. So that's going to give us u to the 3/2 divided by 3/2, or 2/3 u to the 3/2. Plus, now this integral is going to require trig substitution. So if we let x equal 3 sine theta, then dx would be equal to 3 cosine theta. Let's go ahead and model theta. So sine theta would be x over 3. So this would be the square root of 9 minus x squared. Looks like I forgot the d theta here. Let's go ahead and perform the substitution now. We'll have 8 times, this will be the square root of 9 minus 9 sine squared theta. That'll simplify to 3 cosine theta. And then dx is equal to 3 cosine theta d theta. Let's go ahead and simplify this. If 8 times 3 times 3, it's going to be 72. And we'll have cosine squared theta d theta. Let's go to the next slide. Let's go ahead and apply the power reducing formula here for cosine squared theta. It's going to give us 1 plus cosine 2 theta divided by 2. Let's go ahead and simplify this. This will give us integral of 36 d theta plus integral of 36 cosine 2 theta d theta. And now we can integrate this with respect to theta, but now this is going to require another u substitution. Let's just call it v. This is going to be 36 theta plus, if we let v equal 2 theta, that's going to give us 36 times, this will give us an extra factor of 1/2. So we'll have 36 times 1/2 sine 2 theta. Now let's go ahead and perform a substitution here. Let's replace sine 2 theta with 2 sine theta cosine theta. We can see when we do that, that this 1/2 and this 2 are going to simplify out. Let's go ahead and rewrite this in terms of x. Then remember, the limits of integration were from -3 to +3. Let's see how we're going to write theta. Looking at this equation here, sine theta is equal to x over 3. So theta would be equal to arc sine of x over 3. And then here we're going to have 36 times sine theta cosine theta. Well, sine theta would be x over 3, and cosine theta would be the square root of 9 minus x squared over 3. Let's go ahead and leave it like this and then evaluate this at our upper and lower limits of integration. So when x is 3, this is going to be 0. Here we're going to have 36 times arc sine of 3 over 3. Well, the arc sine of 1 is going to be pi over 2. So we'll have 36 times pi over 2. And then again, when x is 3, this will be 0. And then when x is -3, this is going to be 0. this is going to be 36 times arc sine of -1. That's going to give us negative pi over 2. So we'll have 36 times negative pi over 2. And then again, this is going to be 0 when x is -3. So we have 18 pi minus negative 18 pi, which gives us a total of 36 pi cubic units for this volume. So this triple integral had a lot of good integration review topics. I hope you found it helpful.